Welcome back in this video we want to talk about parameters and statistics and kind of set up the stage for what we're going to be doing here in chapter 13. But before we do that, I just want to call your attention back to this big idea of the course where we have this population, and generally speaking, information about the population is not well known. Okay, so what we end up doing is, working with the population and by the way of taking a sample, and we've talked about how to get that sample selected, and once we get a sample selected, then we can conduct our experiment. And then with the experiment, that allows us to do some math on it and make an inference back to the population to say something meaningful about the population. Okay, so that's still the overall picture of the course, and we're starting this bridge here of where we can start to do some inference. And actually, chapter 13 is all about those fundamental principles of making an inference and kind of the mathematical underpinnings here. Okay, but nevertheless, we want to be able to say something about a population, and that something is oftentimes what we call a parameter. Parameter is just a number that describes the population. So we want to know a parameter for the population. For example, the mean human body temperature is 98.6 degrees Fahrenheit. Okay, that's a parameter. But getting that parameter can be challenging. So what we end up doing is gathering data from the sample and then doing some sort of similar calculation for that same parameter of interest in the sample. And when we do that similar calculation, that's called a statistic. Okay, so statistics and parameters are just values we compute from each of the groups, parameters from the population, statistics from the sample. Okay. So we've actually seen some of these parameters and statistics already, right? When we talk about the mean and the mean for the population, that's given by the Greek letter mu. Okay, and just so we're all clear how to put this in if we use equation editor or anything, it would be slash mu. Sample mean, that is x bar. Okay, and then this one you do x slash bar and then space, okay, to get that in the equation editor. Okay. Standard deviation for the population, that is sigma. Okay, slash sigma. Okay, if we like typing all this stuff out. And then sample standard deviation is just S. Okay. Now, we haven't talked about this last one. There is another quantity we will see here in the last video called the sample proportion and population proportion. Population proportion is just represented by P, not necessarily to be confused all the time with probability. Okay, probability can be the sample or the population proportion, sometimes not. The sample proportion, or the proportion that we would calculate using the sample, we represent as P hat. Okay, and this one, to get this into Excel, we would, or in any equation, we would just do P slash hat and then space to get that on there. Okay, if you like using fancy notation, otherwise you can just write P hat. Okay, so we need to be able to differentiate between the quantities provided to us in any sort of information and determine, okay, is this number related to the population or is it related to the sample? Okay, so here is a example where we have to do just that. Okay, so I encourage you to pause the video, take a moment, read through the context, and decide, are the bold-faced numbers that are given to us, are those parameters or statistics, or is each one a parameter or a statistic? Okay, so we have two bold-faced numbers, 36.5%, and we have 3.2%. Okay, so as I look at the language surrounding the 36.5, okay, 36.5 of all reported cases that year. Okay, so that is saying, okay, there are cases reported, and we're looking at among all of them, this is the number. Okay, so this figure, this number is actually a parameter because it is describing the entire population. Oops. Let me erase that. So this is a parameter. Okay. Similarly, if we look at the language around the 3.2, okay, a random sample of all this, found that 3.2%. Okay, so that 3.2% is describing the random sample, and then consequently, since it's describing a sample, it is a statistic. Okay, so again, parameters we compute from population data, statistics we compute from sample data. Okay, so with these contexts that we are going to see, we need to tease out numbers that are given to us. Are they parameters, statistics, and then usually once we are able to do that, that's half the battle. So be aware of that moving forward.